Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of a quadratic function using quadratic formula method. Previously, we discussed the inverse of the quadratic function using the simple function method and completing the square method, and this is the third method. This is the standard form of a quadratic equation, ax square plus bx plus c equal to 0. I would like to recall you the quadratic formula method. X is equal to negative b plus or minus square root of b square minus 4ac over 2a, where abc is nothing but a is the coefficient of x square, b is the coefficient of x, and c is just the constant. You have to remember this quadratic formula for solving for x. Please recall that when solving quadratic equation, one method was to factor them, if possible. In case if the factoring method is not working, then you could resort to the quadratic formula. Am I right? So which would yield the real solutions for any quadratic formula. You can use this quadratic formula as another method to find the inverse function. So here is the quadratic formula. Please notice that quadratic formula will result in two possible solutions, one with the positive and one by the negative sign in between. You will have to make the selection based on the defining the domain and range of the function, because we all know that the domain and range of the original function and the domain and range of the inverse function has to swap. Am I right? Let us begin with a quadratic equation to find the inverse. Your quadratic equation must begin in this format: ax square plus bx plus c. Take whatever algebraic steps you must in order to get your equation into that form, because this is the standard form. Even if you get a different type of equation, you have to rearrange it using any of the algebraic steps. Here is an example: x square plus 2x minus 3. I have drawn the graph. The graph is actually not up to the scale, just graph. Please note that the vertex is negative 1, negative 4. So whenever you get an equation, first graph it and find out the domain and range. So for this figure, x is less than or equal to negative 1 and y is greater than or equal to negative 4. To graph the equation, we used to define the domain and range. Determine the graph of the function either by using a graphing calculator, in case if you are allowed to use a calculator, or just plot various points until you get a parabola. You should assume some x values and plug in those x values one by one in this equation to get its corresponding y value. Hope you all familiar with t-chart method. Using the t-chart, you can graph it. And after finding the graph, you will understand that you will find that this equation defines a parabola with its apex at negative 1, negative 4. Thus, to define this as a function that will have an inverse, define the domain as all values of x less than or equal to negative 1, and the range will then be all y greater than or equal to negative 4. Am I right? Now let us find the inverse algebraically. First we need to rewrite f of x as y, and then interchange the variables x and y. To begin finding the inverse, we used to switch the variables x and y, leaving the equation unchanged except for reversing the variables. So at this stage, we will just replace x for f of x. Did you notice that? Subtract x from both the sides and make one side of the equation equal to 0. Here we have set the left side of the equation equal to 0. Recall that use the quadratic formula, you must set your equation equal to 0 and then use the coefficient in the formula. Am I right? Similarly, this method of finding an inverse function begins by setting the equation equal to 0. So for this sample equation, to get the left side of this equation equal to 0, you must subtract x from both the sides of the equation. So you will get this result: 0 equal to y square plus 2y minus 3 minus x. Now let us redefine the variables to fit the quadratic formula. This step is a bit tricky. Recall that the quadratic formula solves for x in the equation 0 equal to ax square plus bx plus c. So to get this equation, you currently have 0 equal to y square plus 2y minus 3 minus x. So to match that format, you need to redefine terms. Let me explain you. Y square equal to ax square, 2y is bx, and the last two terms minus 3 minus x is c. I didn't do any calculation. I have just compared the answer we got, the step we got with the standard quadratic equation. By comparing, I said y square equal to ax square. In the place of bx we have 2y. In the place of c we have minus 3 minus x. So in the place of a, I mean the coefficient of x square. Coefficient of y square is 1. Therefore, x is equal to 1, and in the place of b we have 2. And c is just a constant, negative 3, negative 1, negative x. Now we have found out the coefficients of x square, x and the constant. So according to our problem, you should find the coefficient of y square, y and the constant c. So a equal to 1, b equal to 2, c equal to negative 3, negative x. Here x is just a number because you have to consider only the term y as a variable. The equation is in terms of y. Now you can apply the quadratic formula. Here is the quadratic formula. Replace b's by 2, a's by 1 and c by negative 3, negative x. Let me show you. Please notice that these are the values for ABC. In the place of ABC in this formula, I have plugged in those values. Okay. Now let me simplify it by working out the exponent and by distributing here. 2 square is 4. And 4 times 1 is 4. If you distribute 4 here, negative 4, negative 3 would become plus 12. And negative 4, negative x would become plus 4x. And the denominator is 2 times 1, 2. 4 plus 12 is 16. So 16 plus 4x under the root. For the two terms, you can take 4 as a common factor out. 4 is a perfect square. Am I right? So you can take it out. 4 can be written as 2 square. If you take that out, it will become 2. Please note that we have 2 in the denominator. So it can be divided. Dividing the terms in numerator by 2, you will get this is the f inverse of x. This final step is possible because you earlier put x in the place of f of x variable. Am I right? Initially. So normally you would place the values of ABC into the quadratic formula to solve for x. However, that you previously switched x and y for finding the inverse function. Therefore, when you use the quadratic formula to solve for x, you're really solving for y or the f inverse. That's the reason I directly plugged in f inverse of x here. And please go through the steps of solving the quadratic formula. So this is how it will work. Please notice that we have got two answers. Please notice that we have plus or minus sign in between. It means we have got two answers. I'm going to list it out separately. You have to write out the two possible solutions. Notice that the quadratic formula gives two possible results using the plus or minus symbol. Write out the two separate solutions to make it easier to define the domain and range and make the correct final solution. You have to pick one which is the reciprocal. Just by finding the domain and range, you can compare the domain and range of the inverse function with the original. So you have to pick the one that correctly swaps the domain and range of the original function. So here are the two solutions. For the square root to be defined, the domain must be x greater than or equal to negative 4. Recall that the domain of the original function was x less than or equal to negative 1 and range was y greater than or equal to negative 4. So to choose the inverse function that matches, you will need to choose the second solution because only this has the reciprocal. F inverse of x is equal to negative 1 negative 4 plus x square root as the correct inverse function. You can check that your inverse function works. To make sure that your work is correct and your inverse is the right equation, select any value for x and place it into the original equation to find y. Then put that value of y in the place of x in your inverse equation and see if you generate the number that you started with. If so, your inverse function is correct. So using the original function. Let me choose x is equal to negative 2 and let me see what y value I'm getting. In the place of x, replace it by negative 2 and see what value for y you're getting. Therefore, y equal to negative 3. Now put the value of x is equal to negative 3 into the inverse function and see what value you're getting. This is your inverse function. Am I right? Now let us use this one. Replace x by negative 3, the answer that we got in the original function after plugging in x is equal to negative 2. 4 minus 3 is 1. Square root of 1 is 1 again. X is equal to, it turns out the result of negative 2, which is indeed the value that you started with. Therefore, your definition of the inverse function is correct in this example. So this is how we proceed to find the inverse of a quadratic function using a quadratic formula. You can pick any one of the three methods that you are very comfortable with. Please feel free to ask any query. See you in the next video.